Welcome to this training video on mathematical and statistical methods in Numpy. Numpy allows us to assess the mathematical functions as the methods of the array class to compute the statistics on entire array and also along an axis if the array is of multi-dimensional array. To illustrate this, let us create an array of shape 6, 3, that is 6 cross 3, 6 rows and 3 columns. Now let us apply some statistical functions like mean, minimum, maximum and some arithmetical functions like sum, cumulative sum, etc. Here I would like to start with the mean to see the mean of the entire array, that is data.mean, and minimum to see the minimum value of the entire array, maximum to see the maximum value of the entire array, sum without parameter change to find the total sum of all the elements of the array. Because sum uses the axis as the first parameter, by default it is none, and data type as the second parameter. It also accepts the condition. So the sum function returns the sum of the array elements over the given axis. So let us find the sum of the elements along a particular axis, like along the rows and columns. Axis is equal to 0 refers along the row axis, and axis is equal to 1 refers along the column axis. Here carefully observe the words along the row axis and along the column axis. Along row axis means go from top row element to bottom row element and find the total sum. So we will get the sum for each column. Similarly, along column axis means go from the first column element to the end of the column element and find the sum. So we will get a sum for each row. So let us use axis 0 to find the sum of each column. To cross-check this data, let us extract the first column using indexing and apply sum to find the sum of all the elements of the first column of that two-dimensional array. So let us extract the first column. Here is the first column. And let us apply sum on this first column. So we got minus 0.76574 minus 0.76574. So we got the expected result for axis is equal to 0. Similarly, the sum along the column axis, that is the sum in each row. To find the cumulative sum of the array, Numpy provides cumulative sum method. Let me create an array to show this. And then apply the cumulative sum to find the cumulative sum of the one-dimensional array. So the cumulative sum means 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 2 is 3, and then 3 plus 3 is 6, and then 6 plus 4 is 10. To find the standard deviation, use standard deviation method, that is values.std stands for the standard deviation. To find the cumulative sum of all the elements along the row or column, we can use the cumulative sum along with the axis control parameters. Let us create an array to show this. To find the cumulative sum along the row axis, that is for each column, use axis is equal to 0. So we got the cumulative sum along the rows, that is for each column. Similarly, to find the cumulative sum for each row or along the column axis, use axis is equal to 1. So here we got the cumulative sum along the column or for each row. To find the cumulative product, similar to like the cumulative sum of each column or row of the array, we can use the Numpy's cumulative product method. Here I would like to find the cumulative product of each row, that is along the column axis. Similarly, you can work with the multi-dimensional arrays and practice well. Thanks for watching this tutorial. I recommend you to continue learning through the series of training videos.